For this example, we are going to let theta be an angle in standard position whose terminal side contains the point 15, negative 8. We are then going to find the values of the 6 trigonometric functions of theta. That means that we are going to evaluate sine of theta, cosine of theta, tangent of theta, and their reciprocals. From what we had worked with earlier, we would, in the past, if our point was on the unit circle, simply connect the x-coordinate with cosine of theta and the y-coordinate with sine of theta. However, the point 15, negative 8 is not on the unit circle. So we cannot simply say that the x-coordinate is cosine of theta and the y-coordinate is sine of theta. Instead, we need to consider what triangle this would make. In many questions, it is typically recommended to draw a triangle to represent what you are working with. In this case, we have the point positive 15 for x and negative 8 for y. That means that we are working with a point that lies within quadrant 4. If I draw that then, 15, negative 8 would be more in the x direction than the y. So it would be a point, say, over here in quadrant 4. I want to relate this still to a right triangle. So what I will do is I will draw a diagonal from the origin out to this point for 15, negative 8. And then I will draw a right triangle up to the x-axis specifically. This represents the angle measure that we are working with, theta, which would be the standard position rotation from the positive x-axis. This would be theta. However, as established before with reference angles, we could instead work with the reference angle for this value, which I'll designate as alpha, and instead establish all the ratios using this triangle and the reference angle of alpha instead, which is still going to retain all the values that we were working with. For the triangle that I have drawn, I would say that the x side length for this triangle would be a positive 15, and I can represent the y side length as a negative 8. Note that negative in this context just indicates the direction that this side length is going. It is going from the x-axis down in the direction of y, which is what negative means. If we want to determine sine, cosine, and the other trig functions, then we need to figure out the hypotenuse side, which we should be able to do simply by using the Pythagorean theorem. If I use the Pythagorean theorem, I can solve for the hypotenuse side, which would be 15 squared plus the quantity negative 8 squared. That would be the square root of 225 plus 64, otherwise known as the square root of 289. For the hypotenuse side, I will always indicate it as a positive because it is a directed distance out from the origin. It is simply how far away is the point from the origin. The negative context would not matter here. So, with this triangle now in mind, where I know the adjacent side to the angle measure alpha, the opposite side of the angle measure alpha, as well as the hypotenuse of the triangle being the square root of 289, I now can say what sine, cosine, tangent, and the reciprocal functions of theta or of alpha would be in this case. Sine of theta for this triangle representation would be the opposite over the hypotenuse, so that would end up being negative 8 over the square root of 289, or if rationalized, negative 8 times the square root of 289 divided by 289. Cosine would be the adjacent side compared to the hypotenuse, so that would be 15 over the square root of 289. Or again, if rationalized, 15 times the square root of 289 over 289. And tangent would be the opposite side over the adjacent side. This we technically could have established even before drawing the triangle because we already had both of those sides. The opposite side in this triangle I have drawn is the -8, and the adjacent side to alpha in this triangle is 15. For cosecant, secant, and cotangent, keep in mind that those are all the reciprocals of sine, cosine, and tangent respectively. So, for example, cosecant would simply be the reciprocal of -8 over square root of 289, or square root of 289 over -8. Secant would be the reciprocal of cosine, so that will be the square root of 289 over 15. And cotangent is the reciprocal of tangent, so that is 15 over -8. A key thing to note about this, particularly if you're going to draw the picture to represent the angle measure you're working with. 15, -8 lies in quadrant 4. We should know from what was established in the unit circle and the concept of all students take calculus that within quadrant 4, the only positive ratios should be cosine and its reciprocal. If you look at the values that we have found for sine, cosine, tangent, and their reciprocals, this holds true. Sine and cosecant are both negative, tangent and cotangent are both negative, whereas cosine and secant are both positive. One last note about this problem. The square root of 289 actually is a nice whole number. The square root of 289 is the number 17. If you choose to replace all instances of the square root of 289 in the solutions with the value of 17, that would absolutely be considered correct. However, I kept it as the square root of 289 because that is a little bit more common of a situation to see. Furthermore, you may not be as familiar with the square root of 289 as you are with some other values such as the square root of 144. In this case, I've simulated this in a situation where I would not need a calculator to calculate each of these values.